One studies the sky, the sun, and the moon as they rise from as the sun rises from the east and sets in the west. One should do it. There is an advanced formula in the higher maths in further maths in higher maths that is actually university maths if one can use, or else one can use a simple mathematical formula. One can use the simple triangle. And the further maths usage of the triangle will be calculus, integration of geometry of the integration of the x, which is the horizontal, the y, which is the vertical, and the z, which is the diagonal, the diagonal projection of lights to form a three-dimensional figure, a three-dimensional sketch or drawing or mathematical sketch, where one can be able to project images of objects. And so to find out how the earth, how the sun looks like, or how the moon looks like on this plate, one would set in the case if one draws on a big plate, one draws the sun on the east of the plate and the moon on the west of the plate. What one would do is one would place the triangle. A triangle is a mathematical instrument which has a length, it has a width, and it has a hypotenuse. And the one would place the angle of the length and the hypotenuse at the edge at the edge of the sun, and the height on the height and the length in the middle, so that the center, the highest point will be the middle of the plate. And then in that sense one can start observing objects. One can take, for example, objects in the east. One can look for the most visible objects, the most visible objects in the east. When one is studying sunrise, for example, one will study sunrise and a human being in the east, and place them at the east and beside, and take oneself to be the center of the observation as the center. And one will study how the movement of the sun, how it moves towards the center, towards midday. One would try to first of all try to think about the movement of the sun towards the observer, which will be in this case me, or you, or any other person. And one will try to imagine how the sun is going to move from the east towards me in the middle. And by placing the triangle close to me, it can be a small triangle, it can be a human-sized triangle, it can be the roof of a house, it can be a tree, which one can use as a triangle, the tree as a height, and the shadow as the shadow of the tree, or the shadow of the house as the hypotenuse, and as the length, as the width and the hypotenuse. And then one can study how the sun rises, how the sun travels towards the center of this triangle. Is it moving upwards towards the triangle? Is it moving horizontally, or is it moving perpendicularly to the triangle? And in that case, is the shadow of the tree going to land on the tree, or a few meters above the tree, or a few meters below the tree, or beside the tree, or not at all at midday? And in that case, using a simple triangle, one can project. Actually, this is actually a simple mathematical question, of a simple elementary mathematical question, where one can deduct the increasing distance of the sun by drawing lines from the triangle to the sun, by drawing a hypotenuse, and then drawing parallel lines in the triangle from the sun to the observer. And then in that way one can be able to check the increasing height of the observer who is approaching the observer at the same velocity, or that the sun is approaching the observer. And in that case, one will try to deduct the height of the observer when he reaches the height of the observed person at sunrise, when he reaches the observer at midday? Is he going to reach him at a normal human height, or is he going to reach him at a smaller human height, or is he going to reach him at a gigantic solar height? And that is what I normally use in the first deduction of to judge to test the theory that the sun travels in vertically circular manner. Because if it travels in a vertically circular manner, it would mean that in a vertically circular manner, it would mean that it will increase the distance. It will increase it will, if one is if I anchor the sun with a human being, it will mean that it will reach me with a human being at either the same height, with a human being either above me at with his same height, or with a human being above me, just as tall as the sun. When I place the human being under the sun, that is rising, at the point where the human being and the sun are equal in height, where they are equal heights, either 2 centimeters or 1.5 centimeters or 1.7 centimeters. It will mean that that is the sun, the same sun that will be at midday, that I would expect to be about 2 centimeters, the diameter, have a diameter of 2 centimeters above me, or maybe a diameter of 2 meters above me. So I will expect maybe when the sun is at midday above my head, I will maybe expect it to have maybe to be still about 2 centimeters, to have a diameter of 2 centimeters, or a diameter of 2 meters, like the human being. And that is the philosophical paragon, the philosophical paradoxical paradigm in the paragon of velocity of interstellar flight. Interstellar flight dimensions. There is the ambivalence in interstellar flight. Interstellar geometrical dimensions. There is the interdimensional question that has to be normally answered when studying a circular object moving towards a person. Otherwise, I believe that it moves in a horizontal fashion, and due to the fact that it doesn't increase its diameter from the east to the middle, to the midday, and to the west. Its diameter remains about 2 centimeters subjectively, or if it is measured with a bigger magnification, maybe 2 meters, as big as a human being. But it normally looks like a 2 meters, 2 centimeters diameter object, which has a radiance, which has an exothermic energy, which is large enough to light up the whole Earth for 12 hours, and that is what I normally judge. I first of all judge the distance vertically, and then I judge it horizontally by placing that same triangle horizontally at my eye level, or above at my forehead level, or above my head, or at tree level, to study the movement and to study that movement orthogonally, to study the movement of the sun across the triangle, imagining that the sun is moving from the one corner of the triangle, of the length of the triangle, to the center, and I study the increase of the circle until it reaches the center by concentrating on the size of the triangle. Otherwise, if I place a ruler on the floor, and another ruler above my head, I find that the sun will never fall on Earth. Will never fall on Earth when I just by observing it as a simple as a simple observer by placing two lines, by drawing two parallel lines. I find that the sun never fell on Earth. The sun has never fallen on Earth. The sun has never fallen on Earth. And the same with the moon. That is, if it would fall on Earth, this object that looks like 2 centimeters diameter object, it will cause a volcanic eruption or an earthquake eruption, a solar lightning with universal dimensions. Because when I study it as an object which is on a convex surface, which is moving on a convex surface from the worm's eye view, but on a concave surface from the universal viewpoint, from the viewpoint of the stars. So that when I look at it as a star looking at the sun, I see it as the same 2 centimeter object, which when it lands on that surface, it will explode like sodium or sodium in water, or like it would either fizzle like sodium in water if it has the same temperature as the Earth, which I don't believe, because I think that the sun is hotter than the Earth. Or it will explode like hot charcoal on butter, or hot charcoal on ice, or fire on textile, or fire on textile, or hot charcoal on textile, or fire on wood, because it can cause forest fires with the same small energy bulb, because that is actually the refraction that one studies. When one studies the refractive powers of the optical powers of the human being, or the optical powers of the animal world, how they study this 2 centimeter object. How big is the sun in the eyes of many animals? Is it 2 centimeters wide, or is it 2 meters wide, as big as the animals, or 1 meter wide, as big as the animals, 1 meter tall? Is it 2 centimeters tall, or is it 2 meters tall? The same object that is warmer than most 2 meters tall other objects, which are a lot bigger than it. And that is one of the observations that I make while studying this energy ball. One, the distance it to the geothermal interactions, the exothermic energy that the sun gives up, and the exothermic energy that the Earth gives back to the sun. Given that the human beings and the plants or animals are energy carriers of the Earth, how much energy the plants and animals as internal capacitors, as energy transformers, how much energy they give the Earth from the sun, and how much energy they give back to the sun from the Earth. And comparing these, I find that the energy that the sun gives is a lot more. Otherwise, the sky is oval, and studying it from a human point of view, or from a worm's eye view, it is larger, because while studying light that is diverging light enlarges objects, enlarges its images, and converging light reduces the size of its images. And the star looks at the Earth as converging light, as solar light, which is converging on a specific point. So that we look at it as a light from the sun, which is a light of a specific, a source of light on a convex object, like light on the eye, or light on the lens, or light on the optical lens. So that the light it refracts, it diverges with the sun. The sunlight diverges the images on Earth, so that they look larger than they could be in reality, because the sun is perhaps not 2 centimeters tall, or 2 centimeters wide, or 2 centimeters long in reality. And as the stars will perceive it, but the human beings will perceive it as 2 centimeters tall object, a 2 centimeters tall exothermic source of energy. and it diverges light and energy on Earth, but it diverges it refracts light through diversion, and through the convex clouds, which through the convex clouds, which through the round clouds, like a ball. They are like a ball on Earth, that when it strikes the ball, the light is reflected over the whole ball, and that one perceives the light on the inside the ball. But when one imagines that source of light with other sources of light, how they see this light, they see it as an image which is more distant from the ball than the human beings perceive it, because even the dimensional the image refraction is also actually quite subjective and not objective, depending on the position of the mathematician. If the mathematician was on the sun, he will see the Earth differently, or if he was on the sun or on the moon or on the stars, he will see it as a very big circular source of energy, which has more energy than the Earth. But it is actually a balanced ecosystem with energy which is actually with a plate which is actually heated for 12 hours and under a lot of heat for 12 hours, and reduced by moonlight for another 12 hours to heat up the same universe. So that it looks like the same ecosystem, the same universe accepts that same source of energy of the plants and animals. By cooling down, they release the source of energy back into the universe, which the sun comes back and places again during the daytime in our plants and animals and the seas and the continents, so that it is actually a continuous dynamic cycle of energy, and it doesn't stop. It is continuous, and one studies it as a ball, while one will study it as light, which can be when one studies it, it is a light which can be above or below a light above or below the ball. If it is above the ball, it also diverges the light and the energy of the universe. It refracts the light in a diversion. And if it is above the ball, it doesn't refract a lot of energy. If it is below the ball, it refracts a lot more energy because of the medium, because of the refractive powers of dense medium, like air and clouds, and otherwise it is actually how one studies concavity. One studies concavity by standing by standing in front of a convex mirror, or by standing behind by standing in front of by standing in front of a concave mirror, and by watching how light from different sources, how a big source of light, how it one can do it by bending a mirror. One can bend a mirror upwards or downwards, and that is how one studies concavity and convexity, by bending the mirror downwards, and how the mirror reduces the size of the objects under it, or how the lens reduces the size of objects under the concave, under the convex lens. The images which would fall, for example, which would fall on the retina. And this is all actually it is actually the same way we study the retina, the retina, the eye, the retina, the fall on the retina, which is concave, and the pupil, which is convex. It is the same. It is actually an advanced science. Otherwise, the eyes are a good addition to the organisms, to the flora and fauna, to study the ingestion of the components of the environment, to study the vortex of the black hole, of the mouth, which is the black hole. And it is the vortex. It is the one that studies it is the gate, so to speak, the gate of the plants which have eyes, the gate of the vortex, so to speak.